Welcome to my physics project. The first topic is kinetic energy, which is energy of motion that is released from stored energy. And the equation is kinetic energy equals half times mass times velocity squared. An example is a car in motion. And this would have higher energy than a water pouring from a faucet, because the mass of a car and the velocity would be greater than the water's velocity and mass. When the larger mass and velocity is plugged into the equation, it results in a higher kinetic energy. The next topic is gravitational potential energy, which is energy stored in an object due to its position above the Earth's surface. And our first example is a skier on top of a 700-foot hill. And the equation is the energy equals mass times gravity times height. So the skier would have more energy than a snowboarder on top of a different hill that is only 600 feet, because when the height is plugged into the equation and both skiers remain at the same weight, the height allows for the energy to be greater for the skier than the snowboarder. The next topic is elastic potential energy, which is energy stored as a result of applying a force to deform elastic options. The equation is elastic potential energy equals half the spring constant times the extension squared. The first example is an archer's stretched bow, where the potential energy has the capabilities to be released, but it's only stored because it has not yet been. And if this archer's extension, so how far it can go, is less than a bent diving board, then this bent diving board before a diver's jump would have more elastic potential energy than said archer's stretched bow. This extension is the same as a displacement to say, so how far this bent diving board or archer's stretched bow can move, which is why the bent diving board would be able to move more. The first example is an action with positive work being done, which is an object moving in the same direction as its displacement. So, when a book is lifted, the work would be less than if a ball fell, because the equation work equals force times distance would mean that if a distance, such as a ball falling from the top of a staircase, the distance would be higher than a book being lifted. The force is moving in the same direction as its displacement, such as when the book is lifted upward and the displacement is positive, and when the ball is falling, it falls down, and also the displacement would be negative from its starting point. Our next topic is negative work being done, which is force and displacement moving in opposite directions. So when a book is lowered, that would have less work being done than if you were climbing a doorway, because the distance of a doorway when plugged into the work equation is higher than such of a book being lowered to the ground. The negative work is the force and displacement going in opposite directions, such as when the book is being lowered, the force applied to it is an upwards force, but the displacement is downwards. And when climbing the doorway, the gravitational force is bringing you down, but you are moving upwards. The last option is an action with zero work being done, so the force and displacement are both zero because nothing is happening. One example is pushing a wall. There is no distance to be done, so when distance equals zero, work equals zero when plugged into the equation. The next example is sitting when there is no movement. So the distance is zero, so yet again when plugged into the equation, force times zero equals zero, so work equals zero. Thank you to my quarantine friends who helped with this video.